So here we are talking about radicals and how we show those as exponent, right? Rational exponents it is called. This 1.1.7. Rational exponents. First, a to the 1/nth power is the same as the nth root of a, or the nth root of a can be written as a to the 1/nth power. Can be written as a fraction. So 27 to the 1/3 power is actually the cube root of 27, which is equal to 3. The cube root of, so I can write it as the cube root of 27 or 27 to the 1/3 power. Either one of them would give you 3. Either one of them is the same. Another thing, if you have a to a power which is in fractions, such as m divided by n, a to the power of m divided by n, it can be written in the form of a radical as radical a to the m power with the index of n. So whatever you have in the denominator will go into the index. Whatever you have in the numerator, it goes into the power of the radicand. It will go under the radical. So here, 125 to the 2/3 power, the 2 would go for the power of 125 under the radicand. The 3 for the third would go to the index. So this would become a cube root of 125 to the 2nd power, which would be equal to 25. Finally, if you have a to the negative power in a form of fraction, to the negative power in a form of fraction, you would write that as an inverse with a positive power, the same thing you had before, right? So it would be a to the minus m divided by n. You write it as 1 over, well, actually the first step is you write this as 1 over a to the m divided by n. And then based on this one, 1 over the nth root of a to the m power. That's what this one. So this one first, it goes to this, and then this. So 4/9 to the minus 3/2 power. The negative can make this one to a 9/4, right? The half in the denominator of the power would make the index here, so you would have a square root, and the 3 would make the power under the square root sign. So 9/4 to the 3rd power, so it will be 27 divided by 8. Rational exponents. Properties of radical. Properties of radicals. We just actually use that to do a nonlinear, use the first property to do a nonlinear equation. Look here, I have the nth root of a to the n power would be equal to a, right? This is simple to understand because the nth root of a is actually a to the 1 over n power. So that's for that. Now to the n power, right? So you write the base using the exponent, you write the a, and then 1 over n times n is equal to 1. So it's equal to a. So this is a step in between to get from here to here. So the 4th root of 5 to the 4th power, basically this 4 and this 4 would do this radical with the 4th power would disappear. It would be equal to 5. right? If the powers were not the same, there's something we can do. We're going to talk about that in a little bit. So that is the first property of radical. Second property of radical. If you have a radical with multiplication of two terms under the radical, so here you have the nth root of a times b, you can separate these two radicals as radical with the index na, or the nth root of a times nth root of b. Again, only with multiplication you can do that. This you cannot do with addition and subtraction. So the third root of 8 times h to the third would be the third root of 8 times the third root of h to the third. The third root of, or cube root of 8 is 2. Cube root of h to the third is h. So it's equal to 2h. If you have division, you can also separate it. So the rules for multiplication and division are very close to each other, but not for addition and subtraction. Most of these rules we have. So here you have the nth root of a divided by b. We say that is equal to the nth root of a divided by the nth root of b. As for example, the fourth root of m to the 8th divided by 16 can be separated numerator from denominator. So you have the fourth root of m to the 8th, the fourth root of 16. The fourth root of m to the 8th, by the way, the step here, the step for this one, is m to the 8th to the 1/4 power, right? You write the m using the exponent property. 8 times 1/4 is 2. That's where this one comes from. Okay? A little step in the middle. So for multiplication and division, you can separate what you have under the radical since they are multiplied or divided. And finally, the nth root of the mth root of a, you can combine the roots and write it under one radical. It would be a radical with the index m times n of a. So for example, the second root of the fourth root of h to the 16, you combine these two and multiply the index. 2 times 4 is 8. So under one index of 8 and h to the 16. And of course, one more time, this one here would be equal to h to the 16 to the 1/8 power. And h, 16 times 1/8 is 2. That's where that number comes from. Finally, it says the nth root of a to the n power is a if n is odd number and its absolute value of a if n is an even number. So it's going back to the first one and explaining this a little bit. It says if n is, the index is odd number, the answer is whatever a is. So the third root of minus 3 to the third, you see that? So n in this case is 3, right? A is minus 3. But since n is odd number 3, then the answer is equal to a, whatever the a is, positive or negative. In this case, it would be negative 3. However, the second root or square root of minus 2 to the second power, minus 2 to the second power, right, would be the absolute value of this minus 2, which is equal to 2. in other words, we're going back to the fact that you cannot take the square root of a negative number, but the cube root or odd root of a negative number is okay. You come up with an answer. Properties of radical. So now that we know properties of radical, we will be able to simplify them. You know, the same way we have been doing with polynomials by factoring and everything. We use these properties to simplify radicals. We have to remember a couple of points when you simplify the radicals. Number one, the powers of all factors under the radical are less than the index, right? So in other words, if you get to the point and you have simplified to this, square root of h to the third, right? This is not simplified enough because it says the power of all factors under the radical should be less than the index. Well, the power is 3 here. The index is 2. So it's not less. So we are not done yet. This actually would be equal to square root of h squared times x, which would be equal to square root of h squared times the square root of x, and square root of x squared is x, so it's x times the square root of x. Now we are done. So the power under the square root should be less than the index. If it is more than the index, we are not done yet. Second point in simplifying radicals. The index of the radical has been reduced as far as possible. The index of the radical has been reduced as far as possible. So if I have let's say the second root or the fourth root of 2 squared. Okay? The index have not been reduced as far as possible because this actually can be reduced further because this is the fourth root of 2 to the second, or is 2 to the second to the 1/4, right? So it's equal to 2 to the 2 times 1/4 is what? Is 1/2. So this has to be actually square root of 2. Now the index is reduced as far as possible. Point number 3. No radical appears in the denominator. So if I come up to this point and end up with 2 divided by square root of x, it's not done. I simplified to this far. We are not done yet. You have to get rid of the square root of x in the denominator because no radical should appear in the denominator. How do you get rid of that? How do you get rid of that radical in the denominator? You multiply both numerator and denominator by that denominator. So you multiply by square root of x divided by square root of x. When you multiply square root of x by square root of x in the denominator, you get x. You multiply 2 times the square root of x, you get 2 square root of x. Now it is done. Now there is no radical in the denominator. This one satisfies 1, 2, 3, all of them. And finally, it says no fraction appears within a radical. No fraction should appear within the radical, right? So you cannot have 5 divided by x like this. Square root of 5 divided by x. You have to separate that. Square root of 5 divided by square root of x. Get rid of the square root in the denominator, multiply by square root of x, square root of x. This one and this one would give you x. And square root of 5 times the square root of x would be a square root of 5x. Now you're done. So in simplifying the radical, you have to remember these 4 rules or laws of simplifying radical. Very important. Here are some examples, and you can see which laws they were actually this one I just did. Number 1, square root of h to the third. Well, the power on the radical is higher than the index. Therefore, that's no good. So you have to simplify it further to this x times the square root of x. Number 2, 15th root of m to the 5. Now this index has not been reduced as far as possible. The 15 as the index is written as 3 times 5, and then m to the 5. Now this 5 and this 5 can cancel, so you would have the cube root of m. Now you're done. For rule number 3, which says no radical in the denominator, 2 divided by square root of 3. There is a radical in the denominator. That's no good. So you multiply both numerator and denominator by square root of 3. So now square root of 3 times the square root of 3 would be 3. And 2 times the square root of 3 would be 2 square root of 3. Now that takes care of rule number 3. And finally, here, no fraction under the radical. Well, there's a fraction under the radical, so you're not done. So you separate the numerator from denominator, square root of x divided by square root of y to the 4th, or square root of y to the 4th would be y squared. So square root of x divided by y squared. Now you're done, and it satisfies all the four laws or rule of simplifying radicals. Now this is a rule that we can use if the radical is a little bit more complicated than before. It says the square root of, let me show you, parentheses, the square root of a plus the square root of b times the square root of a minus the square root of b, that would be a minus b. Okay? By the way, getting rid of the radical in the denominator is called rationalizing the denominator. Rationalizing the denominator. So in this example, we have 7 divided by 3 minus square root of y. So you want to rationalize because you have a square root in the denominator, you're going to rationalize this. So we're going to use this rule here. Okay? So you multiply both numerator and denominator by the same thing except the different sign. So since this is negative, you make it positive. So it would be 3 plus square root of y. 3 plus square root of y. That's what this one is saying. The only difference between the two parentheses is the sign. This is positive, this is negative. Then you would end up with both of them squared, a minus b. That is, this one is squared, minus this one is squared. So when you do that, 3 minus the square root of y, 3 plus square root of y, put parentheses around it, then it would be square of the first term, which is 9, minus square of the second term. The second term is the square root of y. When you square that, of course, the square root would disappear, so it would be 9 minus y. The numerator, 7 times 3 plus square root of y, you can just write it as 7 times 3 plus square root of y, or you can multiply the 7 by it, which would be 21 plus 7 square root of y. Either one of them would be acceptable. This is rationalizing the denominator. As you can see, no longer you have a radical in the denominator, which you don't wanna have. And see, that's what they did. Multiply by 3 plus square root of y. 21 plus 7 square root of y, 9 minus y. That's the final answer. That's the same thing we got moments ago.